Hello everybody, I'm Alexei Khrabrov, the organizer of SF Scala, and actually we have a joint meetup today with SF Scala and Bay Area Haskell user group, and we're at Formation AI, which is a company known for using Haskell and Scala and Elm and really good functional programming languages for real startup production work. So we're very happy to have Meredith Patterson here with us. She's the founder of LangSec. LangSec.org. It's a idea that you can model inputs to a system as a programming language. In my quick understanding, and Meredith will tell us more. But she's doing the talk today, preceding the LangSec workshop, IEEE LangSec workshop, which is held here in San Francisco. So very happy to have you here, Meredith.
Thanks for having me.
So maybe tell us a little bit about LangSec and what got you interested in everything to create it.
Well, it actually kind of started with an argument. So back when I was in graduate school, I was studying formal language theory with a professor named Teodor Rus, a Romanian guy. Wasn't doing security at all. And there was another student in the department who, I used to hang out with him sometimes and get dinner. And we were eating dinner and he was talking about SQL injection. Mm-hmm. And so he described the problem, the idea that you could terminate an SQL query early mm-hmm. by inserting a semicolon into a form mm-hmm. and then adding whatever commands you wanted to after that, and then just finishing it with a comment mm-hmm. Symbol to comment out the rest of the query that the original developer intended. Mm-hmm. And so he's explaining to me that people often try to prevent SQL injection using regular expression blacklists or whitelists. Mm-hmm. And I said to him, that's kind of strange. Why would you try to use regular expressions to mask off things in a context-free language? Yes. SQL lets you, SQL admits, lists of things, for instance.
Yes.
And he was like, okay, well, what would a context-free whitelist or blacklist even look like? And I was like, well, I can see it in my head. I guess I'll just have to turn it into code. And so that ended up being my 2005 Black Hat talk. A system that got called Dejector mm-hmm. It was almost a poor man's prepared statements in a way. Mm-hmm. It was basically a shim that sat between your database and the form mm-hmm. that was that users were submitting things to your database through, mm-hmm. And it would pattern match the parse tree mm-hmm. of the query against a set of templates that matched what you had used when you programmed it. Mm-hmm. And if it didn't match that, if the parse tree was something different than one of the templates it was expecting, it would reject the query. Mm-hmm. And other people had similar ideas, in roughly the same time frame. I think it's about 2007 that Zed Shah, for instance, decided to write a web server. This was when Mongrel was written.
Right.
So he decided to write the parser using a state machine generator called Ragle. Mm-hmm. And the idea being there to rigorously recognize the language of requests mm-hmm. and be able to throw away malformed queries, because the thing is most malformed queries turn out to be somebody trying to exploit your web server or whatever.
Or just wasting your
queries.
At least wasting your bandwidth.
Yeah, exactly. Wasting your bandwidth, wasting your CPU cycles. You should really recognize that quickly and throw it away, mm-hmm. just to save you, time and money. So yeah, like when after he finished writing it, they decided to just as a test to throw up Mongrel behind Apache, and Mongrel stopped like 80% of the the attack traffic that Apache just let through.
Interesting.
Yeah. So I mean, it took several years of people sort of independently realizing, gosh, if we introduce more rigor, more formality to how we handle inputs, we're able to achieve greater security and greater reliability just by not trying to process things that don't make any sense.
Right. Did Apache people learn anything from that? I mean, normally, like, you would just backport Mongrel parser into Apache, right? Like, did they do anything about it?
I mean, that hasn't happened to Apache as far as I know.
Okay.
I mean, nor anything like Nginx. Nginx still uses a giant hand-rolled recursive descent parser, which has given rise to plenty of exploits because hand-rolled parsers are difficult to debug.
Interesting. So, so that's kind of your current focus and the current of the workshop. But you're known for a whole bunch of different things. So how did you arrive at like I noted that you went to study computational linguistics and. Right, and so I know a whole bunch of folks at Penn where I went to grad school, and kind of I see the connection, right? So a lot of folks who like linguistics, computational linguistics, they end up writing parsers, right? And so how does it work for you? Like what attracted you to computational linguistics in the first place? And
well, so I mean, this was back in like 2001, right? I had finished my undergrad. I had actually gotten an undergraduate degree in theoretical linguistics, largely because it was the first major that had managed to hold my interest long enough for me to graduate. I switched majors a bunch, and it took me about 6.5 years to get my bachelor's. So then I spent like a year doing tech writing and decided that tech writing and I didn't have a future together. So I started applying to grad schools. Got into the University of Iowa in their linguistics program. And I figured, computational linguistics would be interesting. I had a bit of a programming background because, my dad had brought home a PC Junior when I was like 8 years old, and I'd learned BASIC. So, I knew a little bit about what I was doing. But, it turned out that the program at U of I was, pretty heavy on the theory side. We got in a corpus linguist from MITRE my second year in the program. But I ended up getting poached into the CS department by the formal language theory guy that I mentioned, because the CS department offered a computational linguistics class. Nice. And he was tenured, so he sort of handed me a couple of papers like over the course of the semester. And invited me to his office to discuss them, and I didn't quite realize that I was sort of being groomed for a PhD, but that's sort of what it was. Yeah, and so at the end of that semester, he was like, would you like to come do a PhD with me? And I was like, sure, I'll try that. And then yeah, but the thing is, like, he was a formal language theorist, and he was more interested in, rule-based systems, which kind of went out of vogue, like, towards the end of the AI winter.
Yes.
And, I was paying attention to the literature, and I realized that, the field was progressing in a more statistical direction.
Yes.
So when the department brought on a data mining guy from UIUC, I was like, okay, I'm gonna jump ship, and that actually turned out to be a mistake because the guy was a total micromanager and eventually got fired for plagiarism. But by that time, I had already rage quit and moved off to the Valley because I got a good job offer here.
Interesting. So in a way, kind of. So then, a more logical question, right? Like we've seen that basically happening. So AI used to be logic and logical systems and inference, and now it's all statistical approach. And same thing with language. It used to be nice categorical grammars and other kind of formalisms, and now it's all deep learning. And so I've been at MNLP 2015 and. Benjo gave a keynote about deep learning, and basically a linguist asked is there anything deep learning cannot do? Do you need linguists, guys? So in LangSec, you're doing grammars, you're doing kind of traditional parsing, right? Which used to be the bread and butter of computational linguistics, and now of course everybody wants to do security with AI, and you go to the airport and you see this silence science and things like that. Just like everybody basically wants to do patterns, but they want to do in deep learning. So what's your take on that?
This is something that the talk tonight is actually going to touch on to some extent, right? But because when we're talking about like a file format or a network protocol, we're talking about something that has a defined specification.
Yes.
Even if the only defined specification of it is the code, and that is a thing that happens, it's still ultimately deterministic.
Yes.
It's unfortunate that more and more often these days we tend to see the only specification is the code, because that's very difficult to reason about.
Yes.
It's one of the arguments that I make is that if you use the tools of formal language theory, you can reason about your protocol before you've actually committed it to code. And so if there are any mistakes in what you're specifying, you can reason about them at the spec level, and you don't have to go and dig through a bunch of code that you've already written to find the mistakes that you made and fix them.
And the code is, of course, it's an accretion of people who churn and
exactly
right. Like it's not really specified because nobody really knows
exactly
what's going on there.
And people's understanding of what the code is supposed to do ends up diverging from what it actually does.
Yes.
But crucially, input languages are definite. This is not the case for natural language. There's a lot of ambiguity in natural language. The title of the talk tonight is "Ambiguity is Insecurity," and that divergence between the human understanding of what the code does and the machine's understanding of what the code does is where vulnerabilities arise from.
Right. So it actually strikes me as it's really something very important, because I think the security which people try to do with machine learning deals with people, right? Basically, people will do kind of crazy stuff, and people are not automatons, so we don't know what they're gonna do, right? We cannot specify their behavior. They're gonna try to send you some packet to some ports, and then they'll try to log in, and they'll poke at the touch sensor with a finger and push some buttons, and there is no real order, right? But obviously, if you send binary packets through the wire, then there is a port above somewhere, right? Or you're entering forms. There is some code behind this. But I'm curious, the world becomes multimodal, right? So a lot of people now who do, for instance, blockchain, which is usually handled by some apps, talking to a distributed system, the input language is, touch screen, like you're touching an app, you're touching touch sensor, you're doing this iPhone X face recognition. You're basically, so can you specify, can you reason about basically all of this? Essentially, you want to record all the key button, basically there is a legitimate sequence of...
you have to decompose it correctly, right? You're talking about a couple of layers here, right? So the physical layer that the person interacts with, right? They're going to touch the screen, and there's going to be some system that recognizes where the touch occurred.
Yes.
And the output, the coordinates that are output from that will be input to the next layer that figures out, okay, well, what region of the screen, as far as we've divvied up the regions for this app, what's been touched, what the coordinates are the input to the system that tells you, all right, well, what got touched?
Yes.
And then the thing that got touched will have some functionality that, is in turn a third layer down, and so on and so forth.
And there's some loop, like there is a UI loop essentially, that usually waits for UI events. So would you kind of reason about, like, would you try let's say there is a bug in there, right? Let's say the OS, like, because it's it's iOS, there is a bug on some kind of UI kit. So you touch in one place, it registers other coordinates, or you push a button, right? So like, in order to debug this, you need to capture somehow a lot of things, like, which people do to it, right? Like you touch like screen, you push buttons. So do you know, like, can we sort of, I'm trying to think, like, can we expand the definition of language, of input, to basically everything you can do, like to my little iPhone, right? Like it's inputs, its surface, its buttons. So the language of inputs to the iPhone consists of, your fingers touching it, you're looking at it, and like everything its camera sees, accelerometer, recording movement, like basically that's what you do to it, right? These are kinds of language. Yeah, yeah, I would absolutely say that. Okay.
And there's an example involving cars in tonight's talk that that basically speaks to that. But another talk worth checking out is Sig Cox's talk from LambdaConf 2017. That's that talk is mostly about user interfaces, but it's about sort of developing a vocabulary and a language for interfaces.
Oh, nice.
And similarly, Perry Metzger's keynote from the LangSec workshop last year. One of the things that he talked about is formalizing the state transitions of protocols as as languages as well.
Interesting. So basically, like, we probably, since we have more inputs, we need to evolve the notion of language, right? Like, we need to include all this stuff.
Yeah, figure out how to characterize them.
So like, what would it be, like, you did the work on data mining Postgres queries. So what would you, like, plan for the next year or two? Like, what would you propose to the machine learning people who do security based on traditional data mining? Like, load all the logs into a gigantic data store and, like, unleash deep learning on this, right? And somehow, like, but I don't know how, like, it's very hard to get annotated data of exploits, right? Because it's sparse. You're not going to get the training data set.
Well, there's two pieces of advice I would give. The first one is, learn from the past mistakes of others. Because big data has been a buzzword in security since 2009, 2010, and people made a lot of mistakes trying to identify malicious traffic automatically. And that actually feeds into my second point, which is never ever ever underestimate the creativity of an attacker. The languages of network protocols and message formats and file formats are constrained. And human creativity is unrestrained. This gets back to what I was saying earlier about the Pigeonhole Principle, right? If you're trying to if you're trying to get a regular expression, to match, like, A to the N, B to the N, it's not going to work.
That's not going to work.
Yeah, like, you can basically always construct a string that will not be what you were expecting.
Yes.
And additional complexity when it comes to when it comes to language power just provides attackers more degrees of freedom.
Interesting. And maybe, the final question, obviously, it's on everybody's mind. You reside in Europe. Everybody receives every day global privacy updates. about the wonderful GDPR, right? And then basically
I live in Brussels, which is even better.
Right? This is the citadel of the bureaucracy, right?
I live on the west side of Brussels. I don't live on the Parliament
And
side.
I thought this stuff is not touching me because it's just a bunch of emails and cookies, but it really hit hard because I like domain names and I like the whois. And one of my domain providers, sorry, this thing is killing the whois. We're gonna delete the whois. We cannot give you the whois anymore because GDPR is killing the whois. And no, this aggression is not gonna stand, man. You're not touching my whois, right?
That's gonna be an interesting one. Yeah.
So how do you think, we're at the beginning of this, and so currently basically the reaction to GDPR is to privacy update and an email, GDPR@ourcompany.com. Complain to that, right? So basically, it's not really doing, but we see an attack on a who is a strong one. What do you think? How do you think this will affect the security field? Will it enhance security of everybody? Will it lead to new innovation? It's just another Brussels bureaucracy thing, globally, affecting global internet users?
I think one very practical effect that GDPR is likely to have is that, for end users, I think, or at least I hope, that a lot of the data that is currently being collected on people is just not going to be collected anymore.
Yes.
You can't own what you don't have.
Right.
So if nobody's collecting it, then it's not going to be possible.
So it's probably it's a good thing, right? At least it's going to be a good thing.
Yeah, I mean, at the end of the day, I think it's ultimately going to be a good thing for users, but it is going to be extremely challenging for enterprises, particularly small and medium-sized ones, to implement.
All right. Well, let's see what happens, and we're looking forward to your talk. Thanks for being with us.
Thanks for having me.
Thank you.